Good afternoon, everybody. My name is Andrew Driscoll, and I'll be talking to you about access control, what it is, why it is important, and how to use it effectively. First off, we'll start off with the definition of access control is who can access what and how. Access control is split up into three different segments. The subject, which is who is doing the accessing, which is a human, a program, or a process. An object, which is what is being accessed, could be a program, a hardware device, a network. And then the methods, which is how to access it, which is usually from the CRUD, which is create, read, update, or destroy, or other methods that include executing, copying, exporting, and importing. So why is access control important? Well, we'll look at Sony and see why their lack of access control made such a devastating effect. Two important points from this story will be accessing everything is bad, and full permissions for everybody is also bad. So now I'm going to read you a short excerpt from the Fortune article written by Peter Elkind that explains exactly why access control is necessary. Starting at about 7 a.m. Pacific time on Monday, November 24th, a crushing cyber attack was launched on Sony Pictures. Employees logging onto its networks were met with the sound of gunfire, scrolling threats, and the menacing image of a fiery skeleton looming over the tiny zombified heads of the studio's top two executives. Before Sony's IT staff could pull the plug, the hackers' malware had leaped from the machine to machine throughout the lot and across continents, wiping out half of Sony's global network. It erased everything stored on 3,262 of the company's 6,000 personal computers and 837 of its 1,500 servers. To make sure nothing could be recovered, the attackers had even added a little extra poison, a special deleting algorithm that overwrote the data 7 different ways. When that was done, the code zapped each computer's startup software, rendering the machines brain dead. From the moment the malware was launched, months after the hackers first broke in, it took just 1 hour to throw Sony Pictures back into the era of the Betamax. The studio was reduced to using fax machines, communicating through posted messages, and paying its 7,000 employees with paper checks. Before destroying the company's data, the hackers had stolen it. Over the next 3 weeks, they dumped 9 batches of confidential files onto public file sharing sites. Everything from unfinished movie scripts and salary lists to social security numbers. So, does access control help? If you want to pause the video and go to look at that link that I provided, that is a list of the recent data breaches dating back to 2000. And you can just see how many records are stolen. And many of these attacks were due to poor access control. So, how do you use access control properly? First off, you need to develop a security plan. This security plan is the overarching theme as to all network security and all computer security should be used. Underneath the security plan, you should develop an access plan. This specifically tells users what accesses they need, what accesses they're going to get, and who should not have access to what. Then, you need to enforce the access policy. You need to ensure that users do not have any extraneous rights, and that those who are no longer with the company and that those who move on to a different position, that their rights to certain projects that they're no longer using be revoked. And lastly, you have to breed the access policy. You cannot make exceptions to it. You cannot just keep rights with people for zero reason. And most importantly, you do not give rights to everybody in the company just because they work there. Inside the access policy, there are 3 different levels. You need to check and track access. You need to ensure that the lowest level of privileges are given, and that you need to ensure privileges are acceptable to the system. So first, we'll do the check and track access. For this story, I will use Alice. Alice needs to work on payroll. Alice is given access to an Excel spreadsheet. Alice then leaves the company. Should Alex's login credentials remain on the system? Clearly that would not be the case. She's no longer in the system. She's no longer working there, so her access needs to be removed. This goes back to the access control policy, where it needs to continuously be tracked to ensure that those who no longer have access should not be given it. Next, we'll use a story of Alice moves out of the finance department into the legal department. Should Alice still have access to the financial system? Clearly not. When she moves over from another job, her rights for one section of the company should be removed and her rights should be given to the next company. This is all done through tracking and audit logs, which are a necessity in the company. You need to know who is accessing what and when and why. Next up is the lowest level of privileges. Bob is a software engineer. Bob is assigned to the project Call of Duty 52 shooting stuff. Should Bob have access to another game called BioShock? Should Bob have access to the entire project or to his only assigned responsibilities? This is very important to ensure that even if you work in a specific department in a company or you work in a specific file system, that you do not have access to the overarching theme. You should always be working on the things and only have access to the things that you need for your job. Next, you need to ensure the privilege is acceptable. All systems have requirements for operation. If Bob is working on a stack, Bob should only have access to push and pop. He shouldn't be able to pop from the bottom of the stack because the system will not allow him to pop from the bottom of the stack. So therefore, if the system doesn't allow it, Bob shouldn't be allowed to do it either. Limiting privileges. This is where the Sony story really takes note. Segmentation is very important. Bob should not have access to the entire company just because he works there. Bob can and will make mistakes. These mistakes should not interrupt any other processes other than his own. Limiting the privileges is a business decision, and access control enforces those business decisions. Later in this slide deck, I'll explain how a proper access control method will not allow Bob to interrupt the entire network. Implementing and enforcing access. There is a model called the reference monitor. In this, access control that is always invoked, tamper-proof, and verifiable will be used. There are two different models. There's the access control directory and the access control matrix. These are models. Implementations of these models can be made through the operating system, a software program, or other means by ways of software programming. Access control directory. What it does. The owner of the file gives permission to a user of the file. Example, Alice creates a document called passwords. Alice gives Bob the permission to write to this file. Bob cannot read from the file because Alice is not giving Bob permission. The positives of the access control directory is easy to implement, and the owner of the file maintains control of all the permissions. However, there are several negatives. Each permission generates a new entry in a table. If passwords is given to the whole company each has an entry. When you have a network of 10,000 computers, that means you have 10,000 entries to access this file. Also, revocation of permissions is fast for one permission, but if you have to take away permission of a file to the entire company, it takes a long time. Also, pseudonyms are required for each permission to have a different entry. Pseudonyms are two different files that both have the same name. One subject may not have two entries for one file. Therefore, one of the file names need to change. This change gets complicated if one person in this triad forgets that they have permissions, requests new permissions, and is granted higher rights than before for the same file. And propagation of access rights creates a security nightmare. Propagation of rights is defined as Alice giving Bob permission, but Bob giving Sally, Jesse, and Sue permission to use the file that Alex gave Bob. Unless Bob specifically addresses to Alice that he gave permission, Alice does not know that Sally, Jesse, and Sue all have access to the file. So then we go to the access control matrix. This matrix model is a table that has columns and of objects and rows of subjects, with each intersection stating the permissions are granted. For example, Alice has permission to read and write on the file server, and she has permission to write on the print server. Bob has no access for the file server, but he controls the print server. This makes adding and revocations of privileges only changes field in the table. Essentially, if you add a privilege, you go to the table to Alice, you go to the print server, and you say she can now read. Access control is visible for audits and tracking. This one spreadsheet will show you all of the permissions from all of the users for all of the objects in the entire company. It's a much faster process than the directory. Negatives, though, is searching through this massive matrix of objects and subjects is highly inefficient. Therefore, the access control matrix is broken down into two different parts. There's the access control list. This list is where each object maintains a list of the subjects that have permissions. It can be set up to include default rights and explicit rights. Essentially saying, if you work for this company, you have this object that you can interact with, say a print server, and you always have a right to write to it. Now say there is a person such as a janitor that has no reason to print from there. Then you can put explicit rights in to say no, you are not allowed to print. Positives. Searching through the permissions of an object is much easier. If you want to know who has access to that object, you have the list right there. And then default rights allow for company-wide use. Negatives is you don't know who all has rights because it's segmented by object. Therefore, if you're revoking one person's permissions over all of the systems, it requires multiple edits of multiple lists. The privilege list. Each subject is given permissions for a whole series of objects. This is great for adding and revocation of privileges of a single user, because you can go right down the line and see what objects they have. But the review of total access by a user is very simplified. Negatively, though, you are unable to reveal how many subjects have permission to a single object. Say you only want 10 people to have access to this object. You won't know that by using the privilege list. Company-wide access to an object requires creating a privilege list permission to each employee. Capabilities. These are unforgeable allowance of a user to do something to an object. According to the security textbook, think of a capability as a ticket. A user has to use this ticket to access files and servers. Capabilities can be encrypted by some type of access control software, and a right commonly found in capabilities is the right to transfer. At some point in the line of succession, the right to transfer can stop, which stops the ability to share that right with more people. Users request from the operating system. The operating system looks up the rights and manages the connection based upon the permissions that are granted. This generally operates within a domain. A domain is the collection of objects to which a process has access. Think about the computer science department not having access to the math department's files. And capabilities, which are the tickets, must be stored outside of user access. And there's other access control goals. There's procedure-oriented access control, which is having us use a specific interface in order to interact with the object. For programmers, think about using private methods. You can control what you put in there, and you get what comes out. You do not get to edit what is in that method. For non-programmers, think about visiting the web. You can't visit the web using any other software than a browser. Then you have role-based access control. This is where your access is based upon the job that you have. If you're a system admin, you generally have full rights. You need to be able to administer the system. If you're an employee, you generally only get the rights that you need for that job. Therefore, this is better because it's based upon the job, not the user. If Alice goes from finance to legal, she'll get all of the legal rights and remove all the financial rights. In conclusion, access control is the subject interacting with the object and how. Policies are needed to determine who should get access. Access control policies track and manage access, give the lowest needed amount of permissions, and make sure the permissions match with the system's intended operation. The two models are the directory and the matrix models, along with the subsets of the matrix models, and capabilities, which all make up access control. Access should be based upon a job, not a person. And access should be managed with procedures, not general access. Think about the data integrity too. If you have any questions, comments, or complaints, please send packets to 127.0.0.1. Thank you.